So this question is based on, we have given an input of like a string, or you can say an array, and it contains only 0 and 1. So we are basically have to do is from the start or from the end, we have to remove least number of these number of operations, like any integer we can remove, like here from 1, or it could be from 0. So we have to do minimum number of operation to finally what we have left in the end should be the sum equal to the given requirement we have been given. For example, here if we take this example 9, 3, so there are 9 elements in this array. In this we have to take we have to find the minimum number of operations, so such that if we remove it from start, or either it can be from end, after that the procedure, the remaining left array will have the sum of 3. So one way to think is that if we took this as normal an integer, and like a string of integer, like we have to find the first nearest one to remove. This way we are able to solve this in a much faster way, because like if you see, like if we have taken this as first, so we have to remove this 0 also, so it took one more operation, rather than we can instantly remove this one and get that. Why we are removing ones? Because it only contains 0 and 1, so some could only be affected by removal of 1 or addition of that 1. So we can't add 1 here, but we can remove 1 here. So the removal of 1 is the nearest one we have to find. So if we want to remove here 2 ones, so first one should be removed from the nearest here. The second one should be removed from here. So this gives us this array at the end, and this has the sum of the 3, and it is the minimum number operation. So what we can do is here, like we can divide this in half of this and half of this, and we can like maintain an array where like what is the placeholder value of the nearest integer, like here 1. So nearest here it is 1, so we have to maintain that kind of integer. So like this 0 is closest to this, so it has to do one operation to get to reach this. So for this 0 it has to do 2 operations. First is this, the removal of this 0, then this 0 to reach to this, so it is 2. So it is the pivot element from here, and if the pivot element here is 0, as you can see, if the pivot element is 0, we can mark it as an infinity and iterate it based on that. So we can mark it here as infinity and iterate it based on that. So using that we can basically do what we take even and odd integers, like the even number of elements in an array and the odd number of elements in an array. So in odd, what we have is the pivot as the middle one, and we only consider one pivot, and we based on this pivot we calculate this. On an even we considered both these elements. So this is kind of complicated to think at first. It is doable in code, but it is kind of complicated to think at this point, because you have to maintain two of these window to the left and the right of the. So these windows kind of complicate things at the start. So what we can do it here is that we can maintain a left and right pointer. We can iterate it in for this part first, then this part first. So it also then complicate one or two more things is that we can maintain this at the first and then maintain this at the second. So it has to iterate here n times, then here n times, and we have to iterate here then this for n by 2 times and n by 2 times. So it is almost like n plus n plus n plus 2 plus n by 2. So it equals to more time complexity than we can assume, because the time complexity for this could lead up to 2 to 10 to the power 5. So any better way we can think of it as this like in this also for dry run we see that if position of left and right, if it is 0, then and this is 1, so this is the less like nearest one, so we just move this here. So this is then it r goes to this position and this is 2, and this is 1, then this has the least position for 1 to go, so we can move this here. So due to this we can move left and right here based on this. So it is kind of like sliding the or like shrinking the window we have taken, like the maximum window we have shrinking from left and right side, but this is not very intuitive to some extent because it has a lot of calculation. So what we can come up with of that is that an array we have given, it is only containing 0 or 1 elements. We have to do some operations and take such left and right, like take this part. In this part what we have to do is that the sum of that part is required, like we have given the given 3, we want to take such part of the element such that it is the required sum of the element. So what we can think of it as that a of l to a of l plus 1 to a of r, and this will range in 1 to n. And what we will do here was that we want an operation of l comma r such that it has a sum which is given to the required number of sum we want, and if it is not, then we just return -1 based on the given question output if we can find that. So what we do is the operation of l comma r. So operation will be that if we take L here, so it from here it will take removal of L minus 1 operations. From here it will take n minus r operation for r, so L minus 1 plus n minus r operations, so n minus L r minus L plus 1. So this will be that. So we have to minimize this operation of L minus r. So to minimize this operation we have to maximize this part. To maximize this r minus L plus 1 part, we can think of this problem as like to find the maximum length of continuous subarray whose sum equals to the given number. So we have to find the maximum length of continuous subarray. So what we can, one of the initial things we can think of is that the total array sum. If the array sum is less than the given value, then we will just return -1. If it is equals to s, then we will return 0 because no operation is required then. So here how we can apply the sliding window technique. So any position we take L and R, we have to move the R. If we move the R, the sum will always always increase, but it will never decrease because it contains only 0 and 1. And if 1 came in next, so if we add that elements into the sum, the window sum, it will always increase the window sum. It will not will be decreasing, so it is non-decreasing. So for L, if we shrink the window, and if we shrink the window, then the window sum will always will be decreasing but not be increasing. So it will never increase because we can remove 0 only and 1 here from exclude that the 0 and the 1 from the window here, which were previously included by R. So we will decrease the sum but we will not increase the sum from the previous window, so it is not increasing. So this is applicable for sliding window because R is non-decreasing and it is non-increasing. So we will just initialize L to 1, the first element. For the code it will be 0, and for R2 you can say it could be 0, but we are going to be from iterating from the start to end, and t equals to 0 for the sum we are taking totaling, and we will maintain a max length. It could be infinity, you can say, or -1 as per the question. So what we will doing is here is that is we will iterate through start to end, and we will add the sum of that element which the position we get at the rth position, while the here the shrinking part is more important because how we are doing the shrinking is more important. So before seeing that, we should know that if we found that sum, like if that window we are increasing and we found that this window is equals to the sum, so we will update our max length based on that. So max length calculation is same as that. We have to find the minimum of that. So what we will do is we will minimize this. So minimum, so instead of maximum here, it should be minimum. So we will minimize this. So after that, what we will do is that we will just iterate through this to 1 to n. If we found that we have to shrink where, so it should be shrink here where when we exceed this desired sum. So if we exceed the desired sum, then we know that we should exclude this part of the elements which are included in the window size. So we will exclude some part of the element, and it should be less than r, because less than equals to r, because we can't have all the elements here. Like we can't want L to exceed the r, and like it will give us wrong calculations for everything, because this is a boundary condition. Then we will just minus that elements what we are removing, and we will just shrink based on this. So for code, what we will do, it is kind of similar. So what we have to do is that we will just take the element, like the elements from the input we have been given, and we will calculate the total based on that. After that, the total, we will just initialize those conditions as like a basic return, and after that we will take a max length. You can take 10 to the power 18, or you can take any kind of length. So LL here is written for my long, and I have defined the LL here as long. So what we will do is that we will iterate the right from 0 to till the end. We will add it to the sum to the element of this, and we will just iterate it to the end. After iterating it to the end, if we find the sum is equals to what we have initially given, we will find the minimum of that. Like if that it is minimum number of operations or not, we can find from here. And to shrink the window, this is the how we are shrinking the window is that if sum is greater than y, then we will just increase that, like we will just subtract that a and we will increase the left after that. So it is in here what we are doing is we are subtracting the left part and then increasing the left part to shrink the window. So it could be like here we are doing is sum that minus of that left part, then what we are doing basically is that left to be adding to that. So we are just doing this, and we can just simply write this here as plus plus to short this code. So this is the solution for that. You can submit it, it's accepted 100% for that. And